phase imbalance can be caused by a variety of problems, such as grounds, shorts, or mechanical misalignment. If there is a phase imbalance, a supervisor should be informed. Now let's look at how a three-phase AC motor that is not operating can be inspected. To make sure that the motor is not accidentally started while it's being inspected, the motor should be locked out and tagged according to approved procedures. For many motors, particularly ones that are exposed to the elements, a heater is used to keep them dry while they're shut down. When a stop motor is checked, it's a good idea to check any heaters to make sure they're operating properly. Sometimes there will be an indicating light in the heater circuit to show that the heater is energized. The heater can be checked to make sure it's energized by measuring the current flow through it with an ammeter. You can begin your inspection of the motor with a visual check for any signs of trouble. The entire motor should be checked for signs of dampness. The bearing housing should be checked to make sure there is no leaking grease or oil. The stator windings can usually be seen through the ventilation slots at the end of the motor. You should look for discoloration of the motor's insulation, signs of burnt insulation, and dirt. If the motor has a wound rotor, the brushes and the brush rigging should be checked for signs of trouble such as broken brushes or loose parts. The surfaces of the slip ring should be checked for discoloration or grooving, and any signs of trouble should be reported to a supervisor. In order for a motor to operate correctly, the rotor must be centered in the stator. Once in a while, you may be asked to check the air gap between the rotor and stator of a non-operating motor to make sure that the rotor is centered correctly. In this case, part of an end bell is removed. The space between the exposed part of the rotor and the stator is checked. To check the spacing at the bottom, a reading is taken by inserting a feeler gauge through slots so that it's between the rotor and the stator. The readings should all be the same. If they're not, it means that the rotor is not centered, and you should report the problem to make sure that it's taken care of. Perhaps the most common maintenance test for a three-phase AC motor is an insulation test. This test is performed on non-operating motors to find out if motor insulation has failed or if it's deteriorating. For this test, a high-range ohmmeter called a Megometer is used. Megometers are available in several varieties. Some are powered by a hand-cranked generator, and others are line-powered. Before an insulation test, the motor is stopped, locked out, and tagged according to approved procedures. The motor is isolated from its power source by disconnecting it at the motor starter or at the connection point at the motor. After the motor leads are disconnected, they're clipped together. The next step is to test the Megometer and its ground connection. First, the Megometer is operated to see if it will indicate infinite resistance. Then the motor leads are connected together to see if the meter will indicate zero resistance. Next, the Megometer's ground lead is connected to ground. The ground connection is tested by connecting the Megometer's line lead to ground at another location. The meter should then indicate zero resistance. The Megometer's line lead is then connected to the motor leads, and the Megometer is operated to perform the test. Typically, the length of the test is 1 minute, but it can be longer. Check with your supervisor to make sure that the proper time is used. In this case, the reading on the Megometer is nearly infinity. In general, the reading obtained from this test should be at least 1 megohm for each 1,000 rated volts, with a minimum of 1 megohm. If the reading is not at least 1 megohm for each 1,000 rated volts, the motor has at least a partial ground. The reading should be compared to previous readings to see if a trend is developing. This comparison is a good way to detect deteriorating insulation before it fails. If the reading is not acceptable, approved procedure should be followed to report it. During the test, the motor receives a charge from the Megometer that must be discharged after the insulation test. This Megometer has a discharge position on its selector switch. With the switch in the discharge position, the motor is discharged for approximately 4 times the length of the insulation test. If there are no problems, the motor's leads can be reconnected after the motor has been discharged, and the motor can be returned to service. In general, most electrical problems in three-phase AC motors occur in the stator. In this part, we'll look at 3 common types of faults to look for in a motor's stator: grounds, opens, and shorts. When there's a ground in the stator, there is low resistance through the insulation between the stator coils and the motor frame. A high-range ohmmeter, called a Megometer, can be used to test for grounds. First, the Megometer is tested to ensure it's working properly. The Megometer's ground lead is then connected to the motor frame, and the other lead is connected to the stator. The Megometer is then operated to perform the test. If no ground is present, the meter will indicate infinite resistance. If a ground is present in the stator, the Megometer reading is lower than normal, maybe even 0. If a ground is found, the next step is to find out what is causing it. Grounds can be caused by chafing of the motor leads against the motor's frame. This problem may be corrected by re-insulating the leads. If the motor is an unsealed motor, moisture may be the cause of the ground. In this case, the stator should be inspected visually to see if there are any signs of moisture. If the ground is caused by moisture, the problem may be corrected by drying the motor. There are many ways to dry a motor. One typical method is to use a heat lamp. If the ground is inside of the motor and drying the motor doesn't solve the problem, the motor will usually be sent to a motor shop to correct the problem. An open in the stator is a break in a stator coil that interrupts or opens the current path. There are two general ways to test for opens in the stator of a three-phase AC motor. The method you use is determined by the way the motor's stator coils are connected. The stator coils can be connected in either of two ways, in a Y connection or in a delta connection. One way you can usually determine how a motor's stator coils are connected is to check the motor's nameplate. If the nameplate doesn't include this information, check the motor manufacturer's manual. The stators of both Y-connected and delta-connected motors can be tested for opens by using an ohmmeter or a multimeter. With either of these devices, a resistance reading is taken for each current path. Now that we've seen what's involved in the test, let's look at an example in which a multimeter is used to make resistance readings. The only way to find out which circuit an open is in is to take a reading for every one of the current paths. When this test is performed, the three motor leads should be marked according to their phases to identify them. In our example, we'll use stickers with letters on them to ID each lead. We'll use the letter A to identify the first phase lead, the letter B for the second phase lead, and C for the third phase lead. The multimeter is set for resistance, and it's connected to lead 1, which is identified with the letter A, and lead 2, which is marked with the letter B. The multimeter shows an infinite resistance reading between these two leads. Next, a reading is taken between lead 1 and lead 3, and the multimeter indicates that there is infinite resistance between these two leads. From the readings that have been taken, it's evident that there's a break in the current path between lead 1 and lead 2, and between lead 1 and lead 3. So it seems likely that the open is in the stator's first coil. The next step, then, is to make sure where the open is. You can make sure where the open is by taking a reading between lead 2 and lead 3. The multimeter indicates normal resistance between these two leads. Since this current path would not have a normal resistance if there were an open between lead 2 and lead 3, the open must be in the first coil. Now, in a delta-wound motor, you always get continuity, that is, an uninterrupted connection, between any two leads, even if there's an open in one of the coils. Now let's see how a delta-connected motor can be tested for an open with a multimeter. After the leads are marked to identify them, in this case with colored tape, the multimeter is connected to lead 1 and lead 2, and a reading is taken. The reading is written down for later reference. Next, a reading is taken between lead 1 and lead 3, and again the reading is written down. At this point, it can be seen that there is a big difference between the two readings. The resistance is a lot higher between lead 1 and lead 2 than it is between leads 1 and 3. This means that the open may be in coil 1 or coil 2. A reading is taken between leads 3 and 2 and written down. This reading is about the same as the reading for leads 1 and 3, and it's about half the reading for leads 1 and 2. Therefore, the open is between leads 1 and 2. Now suppose you check a motor's nameplate and it doesn't show what kind of connection the motor has, and you don't have the manufacturer's manual. In this situation, the motor should be tested as if it's delta connected. If the test is made for balanced resistances rather than just for continuity, it is possible to determine the location of an open regardless of the motor type. In any case, when an open is detected, it's usually necessary to rewind the motor. The last stator test we'll look at is for shorts. A short is an accidental current path of low resistance. When a short occurs, a conducting path interferes with one of the normal current paths. The current takes the path of least resistance, which is through the short's interfering conducting path. A short can sometimes be detected by testing for a balance of resistances in the current paths. For example, a partial short in the stator windings can result in a phase imbalance. However, when there is a short in the stator, the imbalance in the current paths may be too minor to register on a multimeter.